The pendulum studied with the SensorTile.box. Applied physics in a nutshell. The oscillator is a fundamental concept both in classical and modern physics. In its most famous representation, it consists of a pendulum. That means a mass suspended to a fixed point by a string of given length. When displaced to an initial angle and released, the pendulum will swing back and forth with periodic motion, and the mass, velocity and acceleration periodically increase and decrease. If the amplitude of the angular displacement is small enough, so the small angle approximation holds true, then the equation of motion reduces to the equation of a simple harmonic motion. This kind of movement can be measured by a sensor able to detect acceleration and angular speed or displacement, such as an accelerometer and a gyroscope. ST provides many accelerometers, gyroscopes and complete inertial 6-axis units to the market that are capable of sensing rapidly varying accelerations and rotations. In this way, it is easy to monitor the behavior of an oscillating object, so that the main oscillator's parameters can be calculated. For example, the length of the string can be drawn from on the bottom right angle formula. Starting from F, the number of oscillations per second. Once again, the SensorTile.box tool can be easily configured to extract the data of interest. After the download of the STBLE sensor app, open it and select the Expert mode. Configure the input as accelerometer and gyroscope. Set RMS equal to 2 and stream it on BLE or SD card. When the SensorTile.box is oscillating, a sinusoidal pattern is displayed on the screen. The acceleration increases and decreases according to the movement of the oscillating object, generating the typical harmonic motion pattern. As an example, a pendulum with 2 different string lengths has been reproduced. Due to the SensorTile.box orientation, the oscillations are captured on the y-axis. Seven oscillations in a 10-second frame leads to a strength length of 50 centimeters. Correct. Oscillations in a 10-second frame leads to a strength length of 25 centimeters. That's correct.